All right, I'm going to be going over the problems from quiz number 1 in our MCTC math class. I have pasted the order of operations up here in the top right corner because we're going to use that to make sure that we simplify the expression in the correct order. So if we look at this order of operations, the first step says to simplify any explicit groups with parentheses, and there are none of those. Step 2 says simplify any implicit groups. We don't have any of those either. But in step 3, it says start on the left and work our way right to simplify each operation beyond the basic 4. Beyond the basic 4 means the special ones, the exponents, the logs, the roots. You could even have trig functions in there as well. So that means this exponent, 2 to the 5th, is what we need to simplify first. Now, 2 to the 5th means 2 times 2 times 2 times 2 times 2. 2 to the 5th is equal to 32. So I'm going to replace that exponential expression with the simplified value, 32. Everything else is going to stay the same for now. And we'll go back to the order of operations and move on to the next step. Step 4 says start on the left and work our way right, simplifying each step. We always work from left to right. So any multiplication or division that we see in this step from left to right, we're going to do that. And there is a division on the left, so in this example, we'll divide before we multiply. 32 divided by 8 is 4. And everything else I'm going to leave the same. Color change on ya. Now we're working on step 4. We're not done with step 4 because of this multiplication still. We need to multiply these two numbers together. And 0.5 times 14, that's like taking half of 14. That's going to be 7. So 4 minus 7. Now there is no multiplication or division left, so step 4 is done. We can move on to the 5th step, where we finally subtract. And we're taking away a number that's bigger than what we started with. We're going to have a negative 3. So our final answer is negative 3. Question B says, how many total operations are there? Let's count. We did the exponent. That was one step. Step 1, exponent. Step 2, we multiplied and divided from left to right, which means we divide, then we multiplied. And the very last step was to subtract. That's a total of 4 operations. So our answer is 4. 4 steps that we had to do. Question number 2 says, which of the following words best describe the operation in number 1? We always use the last step. That's a funky W. Operation to name the expression. If you haven't written that down in your notes yet, here's the 3rd time you see it, and it's a great time to write it down. So the very last step was to subtract. Right here, since we're subtracting, we call the expression a difference. So the entire thing is a difference. Let's keep going and look at number 3, another simplifying problem. This one does have implicit groups. There's nothing to do inside of the parentheses, so that doesn't count. But there are implicit groups. Implicit groups are like the numerators of a fraction. Here we have two different implicit groups, and we're going to talk more about that on number 4. But in the order of operations, I always need to simplify that implicit group. Basically, I need to figure out what's in the numerator before I can even think about dividing in my fraction. So let's simplify both of those groups. Inside of those groups, I can see there's a addition, but there's also an implicit multiplication. Anytime you have two numbers squished together like this here, the 4 and the 3, the 4 and the 3, that means we multiply. So we're going to have to multiply those two numbers before we can actually add the 12 in front. 4 times 3 is 12. So I'll rewrite 12 plus 12 divided by 12. That was my first operation to multiply. I'll keep track of my steps here because I know we're going to have to count them up for part B. Now that wasn't the only thing I need to multiply. Oopsies. There's another implicit group. Let me just line that back up. There's another implicit group with multiplication as well. So I'll multiply 4 times 3 again. That one had a subtraction symbol in it. That's actually another step. So step 2 was to multiply. We count them each individually. Now, if I look at the expression that's left, the numerators are not completely simplified. So we need to keep going and simplify the numerators. I'll start on the left. We need to add. 12 plus 12 is 24. That's one step to add. We added the 12 and the 12, and then we need to simplify the other numerator. 12 minus 12 is 0. And that was a subtraction. So subtract. Now I'm looking at my simplified fractions and the numerators are simplified. Now I can look at the entire thing as a whole, now that my implicit groups are simplified and they're just numbers now. I have two divisions and I have a subtraction. The order of operations says we have to divide before we subtract. So I'll start on the left. And 24 divided by 12 is 2. That's an operation. So step 5 was to divide. And then I'm going to divide again. 0 divided by 12 is actually 0. That's another division. We've got a lot of steps on this one. And there's one final step here. Subtraction again. That turns out to be the last operation. Oftentimes, subtraction and addition will be the last ones because they're at the bottom of the order of operations. 2 take away 0 is 2. We're not taking away anything. That was another operation. So subtraction is my 7th step. And that means there's a total of 7 operations. If I was going to name this entire thing again, it would be a difference because subtraction was the last step. Question 4. This is Learning Target 1B where we're understanding the difference between implicit and explicit grouping. These were from lesson 1.1. If you struggled with this section, you should be going back to lesson 1.1. Make sure you have the definitions and some examples there. So we have the same expression from number 3, but we're trying to describe an explicit group and where it's located. Why is it explicit? This one's kind of a trick. There are no explicit groups. An explicit group is a group of numbers or operations inside of a parenthesis. And there is a number inside of a parenthesis, but this is not a group. So it doesn't count. There's no explicit groups. Part B says describe an implicit group. Where is it located? Why is it implicit? There are 2 implicit groups. 12 plus 4 times 3 is an implicit group because it's the numerator of a fraction. And we have to solve or simplify numerators before we can divide. Numerators before we can divide. That's what makes it an implicit group. You probably see one other implicit group as well, because there's another numerator. 12 minus 4 times 3 is also implicit group. So either of those would have been fine. I circled it to show where it's located, and I described why it's implicit. Let's look at the very last question, which is on Learning Target 1C, applying exponent rules correctly and justifying. We had a lot of notes on exponent rules. I decided not to copy all 5 rules. I'm just going to mention them as I go. So we're looking at some student work. We're trying to decide if they use the exponent properties correctly. If I look at this entire expression, I can see that you had to use the quotient property to start to get from here to here. The quotient property said if you have the same base, you can subtract the exponents. So if I check their work, they had 5 to the 9th on top, 5 to the 3rd on bottom. And if you subtract the exponents, 9 minus 3 does give you 6. So that part looks good. That checks out. Now they had to have done the same thing. Let me get a different color. For this set here, they've simplified that quotient. We can use the same rule, 5 to the 2nd and 5 to the negative 4th. This time we have 2 on top and we're subtracting a negative 4, which is the same as adding 2 plus 4. So they actually did the second exponent simplification correctly as well. That part checks out. But what they did in the last step here, 5 to the 6th times 5 to the 6th, they used the wrong rule. It does not equal 5 to the 36th. The reason for that is because 5 to the 6th, let's see if I can get my dots here, means 5 times itself 6 times. That's 6 factors. If we multiply by the same thing, we don't have 36 factors of 5. Oopsies, and that. There's our other 5 to the 6th. We don't have 36 factors of 5. We have 12 factors of 5. So our final answer should have been 5 to the 12th. They used the power of a power rule where we multiplied the exponents, but they weren't supposed to. We should have used the product rule where you're adding the exponents. If you struggled with that one, it's a good idea to review that lesson on exponents and those rules. Make sure you have good examples and notes down so that when you retake this, you can do a little better on it. Thanks for watching.